Hi everyone, welcome back. Today I am here to explain area related to circles. Last time I explained to you application of trigonometry in real life. Now today let's learn about circles. So it's not a complicated chapter as well as difficult chapter. It's in the middle. So if you pay interest to the chapter, it will be easy. So without any further delay, let's get on to the video. So let's start the chapter areas related to circles. So the topics we're going to cover from this chapter: area of sector, segment of circles. Now let's learn what is area of circle. The area of circle is pi r square, where pi is equal to 22 by 7 or 3.14, where this can be used for solving problems, and r is the radius of the circle. Pi is the ratio of the circumference of a circle to its diameter. This is the radius of a circle. Let's know the circumference of circle. The circumference of a circle is the distance covered by going around its boundary once. The perimeter of a circle has a special name, circumference, which is pi times the diameter, which is given by the formula 2 pi r. So this full circle, the distance and the boundary around it is called a circumference. From the middle point to the line, it's called radius. And to find circumference, we have to use 2 pi r. Now, these are the main topics: segment and sector of circle. A circular segment is a region of a circle that is cut off from rest of the circle by a secant or chord. You can see this circle. When we use AB line to cut this circle, this part becomes a minor segment and the whole here becomes the major segment. Same for the sector. A sector of a circle is defined as the region of a circle enclosed by an arc and two radii. The smaller area is called minor sector and the larger area is called major sector. This is called as minor. This is the major. Now these are the two formulas that you need to learn from this chapter: the length of an arc of a sector and area of a sector of a circle. The length of the arc of a sector can be found by using the expression for the circumference of a circle and the angle of the sector. This is the formula: L is equal to theta by 360 into 2 pi r. The area of the sector is theta by 360 into pi r square, where theta is the angle of the sector and r is its radius. Here, you can just remember this formula. It's a trick, and when it comes for length, just convert this 2 here. So it will be theta by 360 into 2 pi r. Now, sometimes they may ask questions related to area of triangle. You need to know the formula. So the area of the triangle, normal, it's half into b into h, that is base into height. If it's an equilateral triangle, you have to use root 3 by 4 into s square or a square, which is the side of the length of the triangle. Now these are the other important formula. Area of the major sector, pi r square minus theta by 360 into pi r square. Area of the segment, area of the corresponding sector minus area of the corresponding triangle. This is the major sector segment. Now for the major segment area, pi r square minus area of segment. Just go through a look. Then we'll go to the other slide. Now this is a question. Calculate the area of a sector. So it's given we have to calculate the area of sector of angle 60 degree. So theta's value is given to 60 degree. The circle has a radius of 6 centimeter. So we just have to use the formula theta by 360 into pi r square. R is given as 6 centimeter. So 60 by 360 into 22 by 7 into 6 into 6. You can cut, then it will be 6 into 27, 132 by 7 centimeter square. That was quite easy. On to the second question. Find the area of the sector. Here they have said area of sector with radius 4 centimeter, angle of 30. So theta is 30 and radius is 4 centimeter. Also find the area of the corresponding major sector. So first find the area of sector, that is theta by 360 into pi r square. We will get 4.19 centimeter square. Then they have also said to calculate the area of the corresponding major sector. So we have already discussed the formula 360 minus theta by 360 into pi r square. This is the formula of major sector to find the area. So apply the value. They have already given theta is equal to 30. 360 minus 30 by 360 into 3.14 into 4 square. It is better to take 3.14 because while cutting it will be more easier than 22 by 7. Or else you have to do the long division method and it will consume more time. So the final answer will be 46.05 centimeter square. Now on to the third question. Find the area of the sector here of circle with radius 4 centimeter, angle 30. Find the area of the corresponding major sector. Now we have to consider OAPB be the sector. We have already said the formula of major sector 360 minus theta by 360 into pi r square. Apply theta is equal to 30, then multiply with the radius, that is 4, and give pi is equal to 22 by 7 or 3.14. Then the final answer will be 46.05 centimeter. So let's do this question as well. The length of the minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. So you have to see here that the length of the minute hand of a clock is already given equal to radius of the clock. So that is 14. Radius is 14 centimeter. Angle swept by the minute hand, that is 60 minutes, 360. So that will be 360 into 5 by 60. 1 hour is equal to 60 minutes. So for 5 minutes, 360 into 5 by 60, that will be theta will be equal to 30 degree. Then we have to use theta by 360 into pi r square. Now just you have to put the value. Then you will get the final answer as 154 by 3 centimeter square. I hope you all understood today's chapter. See you soon. Bye bye.